Are you an SRE? A developer? A quality engineer who wants to tackle the challenge of improving reliability in your DevOps? You can enable your DevOps for reliability with Chaos Native. Create your free account at Chaos Native Litmus Cloud.
Hi, I'm Yishai with LinearB, and today I'm going to talk about cycle time. I'm going to talk about what is cycle time and how do you use that to measure and help your dev team improve. I'm going to talk about why cycle time should be the first metric you should be looking at when you're just beginning to introduce metrics and measurements to your dev process. And finally, I'm going to talk about why just measuring and collecting information in metrics and dashboards is a good first step, but it's not enough to really push your dev team and your dev process to its best. I'm going to show the next steps beyond metrics and how you can use them to really improve your dev team. LinearB is a startup that's all about improving dev teams and improving the dev process. We deliver software delivery intelligence by providing dev teams with the right information at the right time in the right place so that they can improve without an effort. So let's start talking about the problem or the goal of measuring the engineering process. Why do we need to measure things? So I think it's pretty common knowledge that you can't really improve anything if you're not able to measure it, if you're not able to compare what was I doing or how was the team doing yesterday, how we're doing now, what has changed. Once you have some baseline and you have some numbers that you can use to describe some model of your dev process, you can start talking about improving, about making these numbers look better and reflecting the improvement that your team is making by adopting better processes, by removing obstacles and blockages during the process. So measuring is important, but how do we measure the work of developers and development teams without really falling into traps like measuring the wrong things, like creating a culture problem where people feel they're being measured for the raw output. We've all seen previous cases where you measure the wrong thing, you get people optimizing for things like code lines or pull requests or commenting in the code. That's not the thing you want to get. And it creates a really bad culture of big brother being stack ranked against the other developers. And we all know that development is an artistic or creative process where measuring raw output is probably not going to get you what you want. So on one hand, you want to start measuring things. On the other hand, you want to make sure you're measuring the right thing. And the right thing in development is the team and the process. Instead of focusing on individual metrics, instead of focusing on technical metrics like code lines, like commits, things that are easy to game and that don't really get you any benefit, you should be measuring the process. You should be looking at how is the team working? Can we find places where the process is not efficient? Can we shine a light on things that kill productivity? And I'm showing here three of the top productivity killers in dev teams. One of them is context switching. Can we eliminate or reduce needless context switching, where people have to switch between tasks, load some new context into their brains, then drop that context for doing something else, then go back? There's a huge cognitive load and a real productivity tax when you switch between tasks. And when you finish working on something, then start looking at a new thing and then go back to your initial or original task, you're going to spend a lot of time. Some research puts that at least 20 minutes just to get back into something that you may have been working on earlier this morning or yesterday. So context switching is a well-known pain in the development process. There's the issue of work in progress, and it's a kind of a dual to context switching, where people like to start things. There's always a lot of things to do. Dev teams are always busy, and it feels good to start things, to get something started on an item. Typically, that's the interesting part of working on an issue or a fix of a bug or some new feature. Whereas pushing something to completion requires collaboration with other people to get code reviews, to eventually merge your code and to deploy it. So a lot of teams eventually end up with a lot of things happening together, a lot of work in progress, and it really takes discipline and mindfulness to be able to keep the work in progress low and focus on finishing things before starting new things. So a lot of work in progress will cause context switching, will increase risk of delivery, and is another well-known pain around dev team productivity. And finally, there's what we call dead value. You've worked on an item, it could be a bug fix or a new feature. You had your pull request reviewed, you made some changes, you finally got this approved, and you merged the code, but now this is waiting to be deployed. In some places, this could be hours, days, weeks, even months at the high end of the scale. This is value that has been created, but it's sitting there until it's deployed and actually helping customers, actually live in production. This is dead value, and you're not learning anything. The team is not learning anything. The company's not learning anything by having that code sit there in your master or development branch, but not deployed. Your risk when deploying things, the more code that is waiting to be deployed, the higher the risk. So being able to ship code all the way into production rapidly is, again, a well-known source of increased productivity, and having dead value in your code base is a well-known pain. So how do we measure the process and the way the team works to eliminate these and similar productivity killers? Notice that I'm not focusing at all about individual developers or about output. This is about looking at the process and highlighting inefficiencies, highlighting opportunities to improve. So the single metric that I'm proposing that you start with if you're not measuring anything today, or that you add to your metrics if you already are measuring things, is cycle time. Cycle time is a pretty well-known metric. It's got some recent attention in the past few years. You can look at the Accelerate book or look at the Dora metrics. And in different variations, cycle time has become a pretty well-known standard for modern measurement of modern dev teams and dev processes. So what is cycle time? Cycle time focuses on how long does it take the team to deliver a piece of work end to end, starting with when we first start to code against an issue. It could be fixing a bug, introducing a new feature, doing some non-functional work. But we begin to code it. Typically, this lives as a branch or a set of branches that progress and the code base and eventually the product and the deployed services are modified through a change in the code, some form of code review, typically a pull request or a merge request that gets reviewed by peers in my team. After some back and forth, it gets approved. It gets merged to the main code base, and eventually gets deployed to serve its purpose in production settings. The time it takes from the beginning to the end of this entire process is what we call cycle time. And when you measure that across all of your bits and pieces of work, all of your branches and pull requests, you get some idea of how quickly the team is able to turn around value. And it turns out in a lot of like research in like the Accelerate book and others shows that there is a very high correlation between consistently reducing and having short cycle time to well-performing and elite-performing teams. Let me drill down a bit into the four main segments of the cycle time and why each of them is important to take to measure and to understand as a separate part of cycle time. So the first piece is coding. Typically a developer begins to work on a new piece of work by creating a branch and starting to code the changes and the additions required to serve the purpose of this change. They could be fixing some existing code or refactoring. They could be adding new code, adding tests, whatever is needed to get this change into the code base. This is typically the work of a single person. Again, there's no always in code development, but typically this is a single person working on a slice or a piece of functionality that's being added to the code base. When that is done and when the developer feels this is ready for review, the coding phase, the developer basically creates a pull request or a merge request or similar process, and the coding phase is over. So coding measures the time it takes for me to begin working on something until it's ready for review. The next phase is pickup, where my pull request is waiting for someone to take a look at it. Pickup is basically a dead, there's no value happening in this segment. It's all about waiting for someone to begin reviewing. So once someone actually picks up the pull request and begins to create some review, begins to review my code, provide some comments, that is when pickup ends and the review process begins. So pickup is how long does it take for the team to pick up a piece of change that I have requested review on and begin to actually review it. Then the review phase is about the entire back and forth dance between multiple people, at least the original coder and one reviewer, sometimes in many cases more than one reviewer, commenting, making additional changes to the code, and eventually reaching a decision that the change is good enough and can be merged to the code base. So the review phase ends when the code is merged back to the code base and the change is accepted. So review captures the time it takes for the team to actually look at a piece of change to the code base, discuss it either in asynchronously or in other means, and reach a conclusion that this is accepted and actually merge it back to the code base. Finally, the deploy phase talks about how long does it take the team to take this piece of code that it's already back in the code base, the code base is already changed. How long does it take the team to actually get this to work in production, to actually serve its purpose by improving the users or customers' experience, by improving some other non-functional goal, by fixing a bug, etc. And once we have completed that, the entire cycle time for this piece of change it can now be measured from end to end. And when we look at this across all of the changes the team is pushing, you get a measure that really captures the ability of the team to quickly deliver work by having pieces of work take less time end to end. You get less context switches because you're not going to have as many things in play at the same time. You're going to have the team focus on starting and finishing things quickly. You will get much less work in progress, reduce context switching, and by having smaller bits that are deployed, you're going to reduce your team's risk around deploying code. And of course, dead value. If the deploy time is short, then dead value in my code base is going to be minimal. So having talked about the 4 segments of cycle time, let me drill down a bit and talk about how do we actually improve? How do we improve on each of these segments? And they each have different dynamics, which is why it's interesting to measure them separately as part of the combined cycle time, and why improving each of these segments leads to better outcomes for the team. And it's only worth measuring if you can improve by improving the measure. So coding, again, this is how long it takes the developer from starting to work on something until it's ready for review. And what we typically see is that coding tends to, the time it takes to code something blows up for some very well-known reasons. First is to have good requirements. It's very common if the requirements are not great. I begin to work on something, I start coding, and then I hit a wall where some edge cases are not well defined. The requirements are not clear. What should really happen in each of these cases? I need to go back to product or to whoever owns requirements and negotiate some clarifications. This is going to take longer. Like by definition, it's going to increase the time it takes me to code this. Notice that we're not measuring actual work time spent. We're measuring calendar time or clock time. So if I started to work, I wrote some code for 2 hours, and then I had to start talking with product for better requirements. That is going to take maybe a few more hours, maybe a day or two. Coding time is going to explode. So having great requirements up front, being able to maybe begin my work by checking out the requirements and really reading through and understanding that they're fleshed enough is a great way to get coding time down, and will also naturally reduce wasted work. If I've started to code something and it's not the right direction and the requirements are changing because they're not fleshed out as they should have been, that is all things. These are all things we can gain by having better requirements up front. The other obvious way to reduce coding time and cycle time in general is to cut down the item of work that I can start and finish working on. So instead of doing a huge change, a huge feature, let's just take one thing, one small thing that we can code, review, merge, and deploy as a standalone slice of what we need. If we can do that, we have chopped down our work. Our pull requests are going to be smaller, and everything, coding obviously, but also the rest of the phases are going to be much shorter because it's much easier to push through a small change, get it reviewed quickly, get it merged, and smaller risk to deploy it than it is to take a huge thing. So if you're working on something and you can chop it down to smaller items that can be individually delivered all the way, then that is almost always a win for the team. Much better predictability about being able to deliver these things, much lower risk, and a faster cycle altogether. And finally, the third contributor to long coding time is areas in my code base which are very hard and difficult, where every change that I'm making that touches those areas is going to take longer because everything breaks, because it's brittle. So by refactoring places in the code that are very difficult to touch, I can improve coding time for the next items and pieces of code and changes to my code base that need to happen. So sometimes by being proactive and refactoring code, we can reduce coding time for the next tasks that we have. So coding, again, if we are able to push that down, we are typically going to end up with smaller pieces of work and probably with a better process for requirements. Otherwise, it's going to be very hard to drive coding time down. The next segment is pickup, and pickup is all about communication and coordination in the team. Remember, nothing happens in pickup. It's all about a pull request or a merge request waiting to get picked up by someone in the team. So by improving the way we communicate around it, so the people know that they need to look at my change and look at my code, and by having some processes in the team to coordinate around this so that no one forgets to review code, so that I don't have to nag others to look at my code, so I don't forget that my code is waiting for someone. All of these measures are going to help push things through faster, and by providing feedback on my changes quickly, I'm able to act while it's still fresh in my mind. If I get your comments on my PR within, I don't know, an hour or two after writing my code, I'm in a much better place to address this quickly and efficiently than I am if I get these comments tomorrow or in 3 days after the weekend. The other thing that can help with pickup is to think about context switching in a deliberate way. Typically, people are coding. Most of my peers in the dev team are going to be coding and busy with their own tasks. And then code review is going to be a context switch for them. By being deliberate about when do I context switch to help review other people's changes, we can be much more efficient. For example, if I'm beginning my day by taking some code reviews instead of jumping into my PRs and my code changes, I'm just starting my day, so I can go and do some reviews without paying the tax of a context switch. If I'm getting back from lunch, it's the same story. If I just finished a meeting, and again, these are all context switches that already happened, I can be deliberate and piggyback on those to take some code reviews while not incurring a context switch tax just for the review. So by being deliberate and by being aware of the importance to drive pickup time down, teams can really learn to be efficient and get a great turnaround and help each other finish things by starting and jumping on reviews quickly instead of having them languish and need to nag and be the task that I'm always pushing to the end of the day, and then I don't have time and so on. The next segment is the review process, and the review process is perhaps the most complex or elaborate segment here because it typically involves 2 or more people. It's multiple stages where people review the code, have some comments, then the original coder needs to get back to this and make some changes or respond. And the way to drive review time down, to have all this, dance of people, coordination, communication, and context switching all happen in a shorter time frame and in a more predictable way, is first of all to have and instill a culture that getting something done is worth much more than starting something. So by helping and by really focusing on finishing reviews that I'm part of, either as the PR owner or one of the reviewers, or even jumping in to help a review get finished and get some agreement on what's needed to be able to merge this. By focusing on done instead of starting things, people in the team can really help reviews, start, be effective, and finish quickly. Sometimes there is a bottleneck. Some teams have dedicated reviewers or dedicated reviewers for parts of the code, and a long review time, as measured as part of cycle time, will indicate that I have a bottleneck. I don't have enough reviewers, and there's a lot of reviews waiting for a few people. So by deliberately adding more reviewers, by reducing or relaxing the requirements to review, I can make sure that review time remains short and there's not too much onus of reviews on just a few people in the team. And finally, in some cases, the review process for a pull request is going to be long because the original code in that change is done the wrong way. It's not well designed. Maybe the choices made by the developer need to be reversed or revisited. So by improving the design, maybe having an explicit design phase when coding, or getting some review before writing all the code. In some cases, at least in those cases where the actual code changes need to be heavily edited, doing that upfront, getting more feedback on my directions and the way I'm suggesting to solve the problem or to make the code change, is more effective in the coding phase than it is in the review phase, because it's going to be less wasted work and more informed work while I'm coding. So these are the main contributors to review time, and by driving review time down, we can get to these better outcomes of having more emphasis on done versus started, better code to begin with, and avoiding bottlenecks around reviewers. Finally, the deploy phase. This is a pretty well-known pain, and also a well-known gain, where modern teams strive to have streamlined deployment where there's zero or close to zero time and effort needed from when a piece of code change has made it and has been merged to the code base, and until it's deployed and is live in production. It's obviously not easy or possible in all scenarios, but it's a pretty common understanding that the shorter the time is and the smaller the effort is to deploy code, we're going to be in a better shape. So things that improve our deploy are obviously CI and CD systems, having reliable tests, comprehensive tests that give us confidence to be able to deploy code that has been merged, and of course to have smaller work items, smaller PRs, smaller changes that are focused on just one thing, much easier to test, much easier to deploy, much easier to roll back, lower the risk of deploying, and that typically lends to faster deploys because we're willing to take on more deploys when we know the risk is smaller. So I've looked at the 4 segments of cycle time, and how each segment has different behaviors and different dynamics that lead to longer times and different ways to address, so that we can shorten each of the segments and end up with a short cycle time across the board. So some of the benefits that elite teams get when they really reduce cycle time consistently across all of the code changes they're driving. So these are like all over. I'm going to talk about a few. So first of all, there's the issue of predictability. Regardless of the way you manage your development work, this could be Scrum or Kanban or a variety of other methods, by having shorter cycles, smaller pieces of work that start and finish more quickly instead of longer and more work in progress where each item takes longer, you get better predictability. You get the ability to say or estimate when this will land becomes much better when your items are smaller and they're shorter in their cycle. You have a much more efficient and short learning cycle. If you are able to deploy those changes, you're making a small change, you get it deployed quickly, you can now learn from how that behaves in production. Did it give you the right benefit or the right deliver the goal that you needed? How are customers responding to this if this is a new feature or capability? Did this actually deliver the CPU load reduction or the database load reduction that you were aiming for? The faster you get this out and actually running in production on real data with real usage, the faster you will be able to learn and make another change or make the next change that relies on the first one. So learning cycle is an obvious win with shorter cycle times all the way to production. By definition, you will have improved the way your team works, communicates, and coordinates. With now everyone being remote or hybrid remote, coordination has become even more difficult. It's no longer a question of swiveling in the chair and hollering to someone, "Can you take a look at my code?" You cannot really improve cycle time if your team communicates or coordinates inefficiently. So this is going to force the way you communicate to be much better. You will have reduced the work in progress. You have less items in play and more items delivered, which typically reduces risk and reduces, again, context switching. You have less things in play. You need to switch context between less things, and you can, even when context switching, this is within a shorter time frame, so things are still fresh in your mind. If I'm able to write my code, get some comments, respond to these comments, make some changes, and eventually finish my work in a day, this is so much better in terms of my cognitive load and being able to returning back to things than if the same process is spread or the same net time of work is spread across 2 or 3 days. It's the same effort, but then I have to remember and go back to things that I've already left behind, and that will add up time and cognitive load. And then by having much smaller chunks of work, which is almost a requirement for great cycle time, you will reduce the delivery risk. Every item is a well-defined change, very small, much lower risk to deliver, easy to revert in case you need to, and compare that to having huge changes accrued with a lot of dead value in my code base until I eventually deploy something. That is going to be a huge risk to deploy. Will require much more elaborate testing and to be sure that this change does not break anything, and a much harder thing to revert once deployed. So these are all just some of the benefits that lead teams get when really driving cycle time down. And I've been talking with some of our customers. We have some customers that are able to drive cycle time down to a day or even less for a typical change, and really are reaping the benefits of having this predictable, short, small items approach to delivering code changes. So some of the numbers that we're seeing across, this is from LinearB's customers. In these numbers are here to show that, yes, it is very, very possible to improve cycle time dramatically by just paying attention, by measuring it with the right tools, by thinking about the 4 segments and applying improvements across each segment as a result of what we're seeing in our measurements. If I'm seeing our pickup time is high, we can invest in improving our communication or creating a schedule to review code twice a day across the team. If our coding time is high, we can look at the sizes of our PRs, the size of our code changes, and our requirements, and so on, like I've described earlier. So by measuring and then paying attention to what I'm getting across the segments, our customers are able to really rapidly improve the average cycle time by 50%, even by 70 up to 75%, which is that's like a 4x shorter cycle time. Instead of typically taking, 4 days, your work can start and finish. Your typical items can finish in a day, this is a huge gain for productivity, for developer well-being, and for predictability across, like, how quickly can I deliver something. That kind of insight really becomes easier when your items are smaller and begin and end within a day compared to a week or 4 or 5 days and so on. So I've talked about measuring the dev process. I've talked about focusing on the process rather than individuals, and by focusing on cycle time and its segments, how we can start learning about the main productivity killers like context switching and work in progress and dead value. But I'm going to say that, measuring is a great first step. You need to start measuring to be able to improve. It's almost like otherwise you're flying blind, and it's very hard for dev teams to consistently improve without measurements. But measurements, is a great first step, but it's not enough. And that is something that here at LinearB we've learned by working with our customers, hundreds of dev teams. And we've seen that there's the first step that you take. So you begin to measure, you begin to improve based on these measurements. You've seen the numbers. This gets you so far, but there is so much more you can do when you go beyond measurements. So why is just, measuring typically gives you some numbers that go into a dashboard. Again, great basis to start improving, but why is it not enough? Because by the time you have a measurement that highlights a problem, for example, if I have a measurement in the dashboard that someone visits every 2 or 3 weeks, and it shows that my pickup time is high, our team typically takes 2 or 3 days to begin reviewing a PR. By that time, it's already too late for those PRs, and it's a lagging indicator of where my problem is. Another reason where measurements alone are not enough to really help the team improve is that the problems and the delays are not evenly spread. It's not all PRs that will take 2 or 3 days. It's some of the PRs that are going to be very quickly addressed and reviewed and stream, cruise quickly and have a short cycle time. And some other part of the PRs or some other piece of my code changes are going to be delayed, are going to be forgotten, are going to be roadblocked. So like anything else in life, this is an 80-20 case or a 90-10, and being able to know where my problems are is very important. So having a metric is great, but now to really solve the problem and improve, I need something that shines a light on the specific PRs, the specific code changes that are stuck, that are going to have a long cycle time and are going to affect the overall average or median or whatever metric I'm looking at. So by moving from a metric to an insight and then highlighting the specific items that need attention, we can start talking about taking action on specific PRs, on specific code changes, not just retrospect action on a measurement or on a metric. And at the end of this, like at the very high end of solving these problems, you get to automation. And I'm showing here in this slide just 2 examples of how we help dev teams improve by moving from metrics and measurements to proactive action and automation. For example, if a specific PR is waiting to be reviewed, pickup time begins to accrue. We don't have to wait until, to wait 2 weeks and look at the metric to know that we have a problem. Once this PR has been waiting for some, predetermined threshold of time, we can now alert the team and say, hey, this PR looks stuck. This PR is waiting for someone to review. It's already been open for, 5 hours, 10 hours, whatever your threshold is. You can now take action and improve this specific PR, improve the eventual cycle time across all of your work. So by highlighting where a problem is beginning to happen, you can let the team address this in real time, curb the problem, curb the growth of pickup or review time or any other parts of the cycle, and eventually your metric will be much, will improve even more. But by solving and automating the way you solve the specific PRs, you're not waiting to see a metric and then think about what went wrong. We can tell you what went wrong or what is starting to go wrong in a specific, item, which could be a branch or a pull request, a very specific piece of code change that your team is working on. So by highlighting and looking in real time what is actually in play right now, what begins to look like it's stuck or delayed, highlight that, give that context to the team, in the right place, not in a dashboard, but like a Slack alert or similar, where this goes to where the team is already living there and communicating there, and in real time now the team can respond and just organically start reviewing that PR or fix the problem and move along. And this, we see that in our customer data, and this improves cycle time by yet another huge jump. So like the first jump is when you start measuring things, and then the next jump, which really puts you into or gives you a chance to go into the elite land, is by automating and finding and fixing the problems when they just begin to happen on specific PRs, on specific code changes, with a very focused alerts and very focused automation to solve those or remove those roadblocks when they just begin to happen. So to summarize, we've talked about cycle time, why this is a great measure to look at the dev process, and why, if you're not measuring anything, that's where you should start. Culturally, it focuses on the process, not on finger pointing to anyone or stack ranking developers. It's about, can we find and empower the team to remove inefficiencies in the process, focusing on context switching, on work in progress, on dead value in the code base. We've looked at the 4 segments across cycle time. We're focusing on the coding segment where the developer is working on the code, then the pickup segment where the team or the change is waiting for someone to begin reviewing it, then the review process, which is about people collaborating to get the code change to a state where it can be merged and actually merging it, and finally deploying it into production. All of these segments together, if we can drive the time it takes for a single piece of work to go through each of these segments, if we can drive that down, we will have improved our cycle time, improved our productivity, removed cognitive load and context switching. And then after looking at measurements, I've shown the next step beyond measurements and metrics, which is driving insights and automation that really helps the team focus on the specific changes, the specific items that begin to look stuck, that roadblocks that are beginning to happen, address them in real time instead of waiting for what the metric will say in 2 weeks or 3 weeks and doing some retrospect thinking. And I've shown how by taking these steps, dev teams are able to really slice and slash down their cycle time by up to 4x improvement in their cycle time in a very short time by adopting a measurement tool and an automation tool. I'm inviting everyone listening to this to join our Dev Interrupted community. We have a very lively Discord community with over 1,500 dev leaders discussing anything and everything that is interesting to development leaders. We're obviously hiring aggressively, so I'm welcoming everybody to take a look and find your dream position at LinearB. And LinearB is free for dev teams, so you're more than welcome to jump on and begin measuring your cycle time. begin improving by measuring your cycle time, by introducing automation to your dev process, and really go all the way to how elite dev teams work. Thank you.